Welcome to our deep dive into the 8085 microprocessor. Get ready for a trip down memory lane, but instead of boring old diagrams, we're doing things LTT style, with claymation. Today we'll explore registers that make this classic piece of technology tick. Imagine these registers as little buckets inside the microprocessor, each with a specific purpose. So buckle up, because well, figuratively, with the 8085's registers. All right, let's meet the workhorses of the 8085, the general-purpose registers. We've got B, C, D, E, H, and L, 6 little claymation buddies ready to store data. Each one has a unique role, but they all work together seamlessly. Think of them like the RAM in your computer, but way smaller and way closer to the action. They are the immediate storage units that the CPU can access quickly. These registers are 8-bit, meaning they can hold 8 ones or zeros, like tiny switches that are either on or off. This binary system is the foundation of all computing. But here's the cool part. They can team up. By pairing up, they can handle more complex tasks and larger data sets. We can pair B with C, D with E, and H with L to handle 16-bit data. This pairing allows for more efficient data processing and manipulation. It's like having a bunch of small buckets that you can combine into bigger ones when you need to carry more stuff. This flexibility is crucial for complex computations. Now, imagine you're the 8085 adding 2 numbers. The process is straightforward, but requires precision and coordination. You could store one number in register B and the other in register C. This separation helps in organizing and managing data efficiently. Then you use some 8085 magic to add them together, and boom! The result might end up in register D. This magic is actually a series of well-defined operations. That's the beauty of general-purpose registers. They're flexible and always ready for the next task. Their versatility makes them indispensable. These registers can handle any kind of data, letters, symbols, you name it. They are the unsung heroes of data processing. They're like the Swiss Army knives of the 8085, always there to lend a helping hand. Or should I say, register. Their multifunctionality is key to the CPU's efficiency. Think of them as the behind-the-scenes crew on a movie set. They might not be in the spotlight, but they're essential for getting everything done. Without them, the show wouldn't go on. Let's move on to our next stop, the accumulator. This is where things get even more interesting. If the general-purpose registers are the workhorses, then the accumulator is the star of the show. This 8-bit register, often called A, is like the main character in our 8085 story. It's the go-to register for arithmetic and logical operations, kind of like the lead actor who gets all the best lines. Imagine the accumulator as a dedicated workshop within the 8085. It's where the magic happens, where data gets transformed, combined, and manipulated in all sorts of interesting ways. The accumulator works hand in hand with the arithmetic logic unit, ALU, which is like the set of tools in our workshop. The ALU does the heavy lifting, performing calculations, but it always uses the accumulator for input and output. Think of it this way. You want to add 2 numbers. One number goes into the accumulator, the other number goes into the ALU, and the ALU spits the result back into the accumulator. But the accumulator's talents don't stop there. It's also involved in logical operations like AND, Oregon, and XOR. And let's not forget about data transfer. The accumulator is the main point of contact for moving data in and out of the 8085. So, you see, the accumulator is a pretty big deal in the 8085. But even the biggest stars need a supporting cast, and that's where our next group of registers comes in, the special-purpose registers. All right, we've met the workhorses and the star, but what about the rest of the crew? These unsung heroes play crucial roles behind the scenes, ensuring everything runs smoothly. That's where our special-purpose registers come in. They're the directors, producers, and scriptwriters of the 8085 world. They might not always be in the spotlight, but their contributions are invaluable. First up, we have the program counter, PC, a 16-bit register that's basically the director of the entire operation. It orchestrates the flow of the program, ensuring each scene transitions seamlessly to the next. It keeps track of where we are in the program, pointing to the memory address of the next instruction that needs to be executed. Without it, we'd be lost in the script. Think of it like a movie script, with the PC highlighting the line we're on. It's the guiding light that keeps the story moving forward. Next, we have the stack pointer, SP, a 16-bit register that manages the stack. This is like the backbone of our backstage operations. Now, the stack is like a temporary storage area in the 8085's memory. It's a place where we can keep things safe until we need them again. It's used for storing data when we need to free up the registers for other tasks. Kind of like a backstage area where actors can hang out when they're not needed on stage. This ensures the main stage remains uncluttered and ready for action. The stack pointer is like the stage manager, making sure everything runs smoothly backstage. It keeps everything in order so the show can go on without a hitch. It keeps track of where data is being stored and retrieved from the stack, ensuring that everything stays organized. Without it, we'd have chaos behind the scenes. Then we have the instruction register. This register might seem minor, but its role is pivotal. This guy's like the actor who only has one line, but it's a really important line. It ensures the right instruction is delivered at the right moment. It holds the actual instruction that the 8085 is currently working on. This is crucial for the processor to know what to do next. Imagine the instruction register as a teleprompter. It displays the current line for the actor to read. The program counter points to the right line on the script, the instruction in memory, and the instruction register displays that line for the 8085 to read and execute. Together, they ensure the performance is flawless. We've talked about storing data, crunching numbers, and even managing the backstage area of the 8085. But there's more to it than just these tasks. But what about making decisions? That's where our next guest star comes in, the flag register. This component is crucial for the 8085's decision-making process. This 8-bit register is like the 8085's very own fortune teller, holding clues about the outcome of the previous operation. It helps the microprocessor understand what just happened. It's divided into individual bits, each acting like a signal flag, telling us if something is 0, negative, or if we've got a carryover from an addition, and so on. Each bit has a specific role to play. Think of it like this. You just baked a cake, performed an operation. The process is complete, but you need to check the result. Now, you want to know if it's any good, check the outcome. This is where the flag register comes into play. You poke it with a toothpick, check the flags. This simple action gives you valuable information. If the toothpick comes out clean, the 0 flag is set. You know the cake is cooked. This tells you the operation was successful. There are 5 main flags in the flag register, each with its own special meaning: sign, 0, and more. Auxiliary carry, parity, and carry. Each flag provides specific information about the operation's result. They're like little spies, reporting back on the status of the 8085's operations. These flags ensure the microprocessor knows exactly what happened. The sign flag tells us if the result of an operation is positive or negative. This is crucial for understanding the nature of the result. It's like checking if your bank account balance is in the red or the black. This helps in making further decisions. The 0 flag, as we saw with the cake example, tells us if the result of an operation is 0. This is a clear indicator of success or failure. And finally, the carry flag is the most common one you'll encounter, telling you if there was a carryover from an addition or borrow from a subtraction. This is vital for arithmetic operations. These flags are essential for making decisions in our 8085 programs. They guide the microprocessor in its next steps, ensuring accurate and efficient processing. We've met the cast, from the versatile general-purpose registers to the specialized roles of the accumulator, special-purpose registers, and the decision-making flag register. But now, let's talk about how they all work together in perfect harmony, like a well-conducted orchestra. Imagine the 8085 microprocessor as a grand concert hall. Each register has its own part to play, its own instrument to master. The general-purpose registers are like the violins, always busy, playing the melody and supporting harmonies. The accumulator is the soloist, taking center stage for those crucial arithmetic and logical operations. It's the star performer, the one who captures the audience's attention. The special purpose registers are the conductors, keeping everything in sync. The program counter sets the tempo, guiding the flow of the music, while the stack pointer manages the transitions, ensuring a smooth performance. And let's not forget the flag register, the audience. It reacts to the music, its flags waving like enthusiastic applause or hushed whispers, signaling the outcome of each musical phrase. Every instruction executed by the 8085 is like a carefully orchestrated movement, with each register playing its part to perfection. Data flows between them like musical notes, transformed and manipulated in a symphony of ones and zeros. It's a beautiful dance of data, a testament to the elegant design of this classic microprocessor. Each register, with its own unique role, contributes to the overall performance, creating a symphony of computation. And that's a wrap on our claymation adventure through the world of 8085 microprocessor registers. We've seen how these tiny storage units work their magic, from the workhorse general-purpose registers to the star power of the accumulator. Thanks for watching! If you found this video helpful, don't forget to like, share, and subscribe for more tech insights. Curious about the internal workings or examples of register usage? Let me know in the comments below. I'm always up for a good tech chat. Until next time, keep on learning, and remember, tech can be fun.